Okay, this is Math 2. We're going to do 132 to 138, and I'm going to stop right after 135 so that I can do another video because I think 133 is going to be a long one. For the first one, it says for each equation or for each function, write an equation for the inverse. How can you check if your equation is correct? So I'm going to do the setup for the first one. The second one you should be able to do on your own. So this is just the hints and the steps from online. It says write down the steps of the original function. So if you take your x, right, you're multiplying by 2 and then you're adding 3. So step 2, write down the steps that will undo the original function, which in this case is subtract 3, because the undoing of adding 3 is subtracting 3. And then undoing multiplying by 2 is dividing by 2. So if you take this and write a function with it, then what you get is x minus 3, because you're subtracting 3, and then you're dividing by 2. So your function, your inverse function of your original, f inverse of x is equal to x minus 3 divided by 2. Okay, and you need to do the same thing for b. Please write down the steps of what you're doing first, and then undoing steps, and then your last thing is going to be g inverse of x is equal to, and then write your equation down in here. All right, that was 132. 133. You weren't supposed to see that. You weren't supposed to see that either. What actually happened to the equations? Okay, well, this is a very strange problem, and I forgot to print it, so I'm not going to take the time to do that. So, on 133, it says, given the information, there's a text box, and there's a, oh shoot, what is it? I forgot the actual question. Chapter 9, 9.3.4. No, 4.1. Wrong one. What are we doing? Oh, there's a text box, okay? I'm sorry, an XY table, and then there's a graph. So, if you don't know how to find the graph, the equation of the graph, well, here's the graph, and then here is the, here's the dots, right, from the XY table. I just plotted them on there. And then here's the graph. So the graph's equation in itself, in order for me to actually get this, you actually have to know the equation of it. So the vertex is at -2 and 4, and then the y-intercept is at 0 and 24, right, as far as I know. So how do you find the equation of this line? Because in order for me to actually use the graphing function, you have to know what the graph is, the equation is, so you can plug it in. So I did it the the way that I told you guys how to do it. So I did, okay, y equals a times, I know the vertex, so I can put it in vertex forms, and it's to the left, so it's going to be x plus 2 squared plus 4. And then I know one of the points. In this case, I know the vertex. It doesn't really matter as long as you don't use 0, 0. So 0 and 24 should work just fine. The x is 0. The y is 24. So we have, let's see, we have y equals, or 24 is equal to, we don't know the a, so we're going to find the a. X is 0 plus 2 squared plus 4. So 24 equals a times 2 squared plus 4. 24 equals 4 squared plus 4. Subtract 4 on both sides. 20 equals 4a. So that means a is equal to 5. Okay. So now when I graph this, I'm going to graph, okay, y equals 5 times x plus 2 squared plus 4. So that is what I plugged into the Desmos app, and I got this graph right here. All right, and then I plugged the points in, and the question was, if I'm not mistaken, for 133, it was describe each function completely. Okay, well, here are the dots, right, and there's the parabola, and there's the function, so One's a parabola, one doesn't really look like a parabola. We don't really know what it's doing. Maybe it could be a really wide parabola if we connect the dots, but right now we don't know. And then sketch a graph of each function on the same set of axes. So there it is. Based on what you know about the quadratic and exponential growth, okay, so I guess there's our hint. That one's the quadratic, and the little dots are going to end up being an exponential function. What will eventually happen to the graphs of the function as s gets large? So in order for me to actually do that, you need to know what the equation is of the dots, because just going from 0 to, you know, what is that, 5, isn't really going to do anything for you if you take this, if you zoom out, you want to know what it's going to do. So you actually need to find the equation of that exponential function. And technically this is a Math 1 skill, but we can still work it through. So what I did was I took the table, and since my hint was that it was exponential, the question is, what do you multiply? Because technically you need a multiplier. What do you multiply each number by to get to the next number? And, okay, ignore, you can't see. Good. There we go. So, ignore that until I'm done to it. So, if you look at the table, what do you multiply each one to get to the next number? And if you know how to figure out how to use your calculator correctly, you figure out that you're multiplying 0.5. Yeah, 1. You're multiplying by 1.05 each time, multiply by 1.05 each time, multiplying by 1.05 each time. Now, if you didn't know that it was multiplication, you can probably tell right away that it's not addition. That's definitely for sure. 10 plus 0.5 is 10.5, but if you add 0.5 again, you're not going to get 11.025. You're going to get 11, and then so on and so forth. So it's definitely not adding to go up. That's your clue. If it's not adding, maybe it's multiplying. And sure enough, it is. It's multiplying by 1.05. Exponential equations work in y equals ab to the x, where a is your starting value, or better known as your y-intercept. So in this case, our y-intercept is going to be the 10. And b is, what are you multiplying by every time? So an equation is going to look like 10 times 1.05 to the x power. So when I plug this into the graphing calculator, or Desmos is what I'm using, I'm plugging that in, right? And I get something that matches my little dots perfectly. Yay! But I still don't know what it's going to do when it's really large, because right now, if you look at it, the parabola is still the fastest one out there. So I need to zoom this out. So I kept zooming out, and the parabola was still in the lead. And I decided, okay, that's just not going to happen, because I know exponentials always end up winning, especially if you're trying to compete against the parabola. So I zoomed out and I changed my scale. And sure enough, changing my scale actually did help. I scaled all the way out to 250,000, and I scaled the x to 200-ish, or in this case 300, I think is over here. And the parabola is obviously the darker one, right? And then this is the exponential, and look and be, I was right, yay, math always wins. Somewhere after 200 for the value of x, the exponential overtakes the function of the quadratic and wins the race, which basically answered the question of what will eventually happen to the graphs of the functions as x gets larger. Eventually, the exponential does overtake it, even though at the beginning, it looks like it might not. All right, and you have to keep on messing with the window for that. Okay, so that was 133. 134 is a checkpoint problem. I'm not going to do any of these on here, A through D. If you do not know how to solve any of these problems, we're in trouble. You should at least have an idea how to do A, B, and C. Maybe D is a little difficult. You are supposed to do them yourself. Okay, and then if you have any questions, I will see you Thursday after school at tutoring if you're still stuck on A through D. You can check your answers by referring to checkpoint 9 materials located at the back of your book, right? And then it says ideally, you notice there aren't any hints or answers for this online either. Ideally, at this point, you're comfortable working with these types. If you feel you need more confidence, you can do some of the reference problems from the back of the book. Or if you see me, I can show you where the reference problems are in the back of the book so you can practice some more with these. All right? So if you don't know how to do them, again, I'll see you during tutoring. 135. And then after 135, I'm going to stop the video and start another one. It says f of x equals x squared plus 2x plus 1. G of x is x minus 3. Write the following functions. Okay, I guess we're just adding them. So if f of x is 2x plus 1, so x squared plus 2x plus 1 plus g of x is x minus 3, then we really just need to clean this up. So we leave the x squared. 2x plus x is 3x plus 1 minus 3 is minus 2. Okay, so s of x is equal to this function right there. Done. Now subtracting, the problem with subtracting is people always forget the parentheses. So we have x squared plus 2x plus 1, right? We have x squared plus 2x plus 1 minus everything that was g of x goes into the parentheses. And this is where people typically lose points. So we have x squared plus 2x plus 1 minus x plus 3, because there's a negative 1 out here that needs to get distributed. And then m of x is going to be equal to x squared. Oh man, sorry, I got lost. Plus 1x plus 4. There we go. And then 2 times f of x, well, 2 times f of x is x squared plus 2x plus 1. So that's going to be equal to what when you put it through? And then g of x minus f of x. Okay, so we're just going backwards, no problem. So g of x was x minus 3 minus everything that f of x was, which was x squared plus 2x plus 1. And then you need to distribute and then clean it up some more. All right. So that was A, B, C, and D. Okay, so I'm going to stop here with this one, and then I'll pick up on the other ones.